So the question we're trying to answer this time is, which of the choices below is the best description of the motion depicted in the motion map at left? You might be tempted at first to go ahead and check out these answer choices and then simply memorize which answer choice goes with each type of motion map. But I would caution you against doing that. Instead, let's try to answer a few simple questions and see if they lead us to any conclusions. First, the scenario I've chosen for these examples is a salmon swimming in a stream. So we got some water here. There we go. Now let's assume the salmon always swims as fast as he can, but his speed changes depending on how strong the current is flowing, and in which direction, of course. Let's watch him swim. Okay, now answering the questions, the direction the salmon is swimming is positive. And it appeared that he was slowing down. You can also tell this because the dots are closer together the further you go. And why? Well, we said the only reason the salmon's speed would change is because of the current. So it must be that the current is flowing in this direction, which would be the negative direction. So that means a negative acceleration. When we have a positive velocity and a negative acceleration, he slows down. So we're looking for positive velocity, negative acceleration. There we go. Okay, next example, same question. So let's go ahead and check out our motion map. We got our salmon. Here's the stream he's swimming in. All right, and let's see how he moves. All right, so the direction there looked positive. He appeared to be speeding up, and you can also tell that by the spacing. It's getting larger. And why? We said the salmon's speed is only going to change if the current changes. So the current must be pushing in this direction, which is the positive direction. So we have a positive velocity and a positive acceleration. He's speeding up. Example 3, same question. First of all, look at the motion map. What do you notice that's different about this one from the first two? All right, let's check out what that means for our salmon. Aha, he's facing the other direction. So, here's our stream, and let's watch him swim. Aha, so direction this time was negative, and he was slowing down. Now, you might think slowing down, the acceleration must be negative. But that's not always the case. Remember, for our salmon, the only thing that's going to slow him down is if the current is pushing in the opposite direction, right? The current must have been pushing this way for him to slow down. That is the positive direction. So in this case, we have a negative velocity and a positive acceleration for him to slow down. Let's check our answer choices. And negative velocity, positive acceleration, there we are. Last example, same question. Here's our salmon swimming down the stream. Once again, we've got him moving in a negative direction. Let's see how he looks when he's swimming along. All right, looked to me like he was speeding up. And why was he speeding up? Well, like always, it must be the current. So the current was pushing this direction for him to speed up, right? That is the negative direction. So we have a negative velocity and a negative acceleration this time to speed him up. Try to generalize our 4 different examples and make some sort of organizer for this information to help you study.